Hello friends. So in previous video we saw the basic coding architecture of C programming. Today we will learn about data types in C. So in C we can divide the data types in three categories. First one is primary. So primary is the primitive data types that C provides. So it's like integer, character, floating point, double floating point, and void. So integer is for to store the integer values, character to store the characters, floating point to store the decimal values, double floating point is to store the long range of the float values. Void is a special category. It is a generic type. So you cannot declare any variable with void, but you can make a void pointer to store any variable's address. Okay, so I will explain void pointer when we will cover pointers. But for now, you can just take it that void is a type. It means generic type. It supports generic. Then comes derived type. In derived type, it's like on top of your primary data type with the combination or in a form. If you are creating another data type, that is your derived. So array, if you take array, where you club multiple elements of same type, that is called array. So let's take example of integer array. So integer array is nothing but collection of integer elements, all integer elements. There will not be any other type. It will be only integers. Similarly, if you take character array, then it will be characters only in that variable. Second type is pointer. Pointer is not actually a type, it's more like to hold the address of any other data type variable. So let's say if character variable is there, so character pointer will hold the address of character variable. Character pointer cannot hold the address of integer variable. So that's why pointer is in derived category. Now comes the function. So function is uh, a name of a function or a routine or a procedure in C. So there is a special syntax to declare your function. Then comes reference. A reference is similar to actually pointer, but in pointer it is to hold the address of another variable, but reference is kind of an alias to the existing variable. So it will not hold any memory. It will just point to some other variable. So there is no additional memory involved in case of reference. Now third category is user defined data types. So in that first one is structure. So structure is very similar to your array. The only difference is in array we can store only same type elements. So if it is integer array, then all elements will be integer. Whereas in structure, you can mix it. You can within a structure you can have a integer variable. You can have a um, character or float element. So you can club different types within a single structure. Union. Second type is union. So union is again similar to structure, but the difference is structure if let's say having two member variable within structure, so final size of structure will be addition of those two member variable, the total size. Whereas in union, at a time only one variable can hold the value, and maximum size of union will be defined by the largest element, largest member element of the union. Third type is enum. Enum is kind of your integer constant. So you can define the constant in more meaningful way. Last one in user defined is type def. So type def is again used to give meaningful name to your data types. So let's say you have integer and you want to give it some like 4 byte. Your compiler supports 4 byte integer only. So you can typecast int to int 4. So wherever you use int 4, whoever is reading the code, he will understand that okay, this integer is of 4 byte. So type def is used for that. We will see all derived and user defined types in upcoming videos. Today we will only learn about this basic one, the primary. So let's see, we will start with programming now. So here we have our online GDB. I have deleted all the existing content. So let's write from scratch. So first let's see about char variable. Char ch equals to, let's say, a. So this is very basic declaration of your char variable, and I'm also initializing it with value a. So if I have to print such variable, then %c is your format specifier. I will tell more about format specifier a little later. So here if we do this much, format specifier and your variable. With this, if I do run here, okay, let's see. So we got our output A. If I do capital A, then we'll get capital A. Okay, so this is about character. Now let's see about integer. Again, syntax is very same. Integer A, then some integer value like 56. And to print such variables, printf. Here format specifier will be %d. And then variable name, semicolon. So it has printed the value of A. Now let's see float variable. Float f equals to some float value like 5.6. Printf. To print float, you need %f. So for float, you will see the output like this. 5.6 was our original value, and then some zeros. So this is actually our after decimal point, this many number of digits it supports. So if you want to only display, let's say after decimal, let's say only one digit. To do so, you have to introduce here 0.1. This will tell, okay, I want only one digit after my point. So if you run here, you shall see 5.6. What if I want two digits after point? Then you can put 2 there and it will give you a 0. You can, let's say I have after decimal I have 3 values. So 6, 7, 8, 9. And in this case, if you run with the 0.2, you will see only 5.67, not 89. Okay, it has rounded off actually. If I put 0, 1, 2, then it will not do the round off. So in this case, when it has rounded off, it is only 5.67. So now let's see double. So actually there is only difference in terms of storage between float and double. Float is of 4 byte and in double is your 8 bytes. So storage capacity is different. Other than that, both float and double are used to store the floating point values. To print a double, you need to use LF, format specifier. So you shall see the value of float. So this is about your primary data types. I also mentioned about void. So as I said, we cannot declare any variable with type void. If you do void, then let's say a, with this much only you will get the error like this. Variable or field a declared void. The reason is when you say void and a variable, so compiler does not have any information about the storage, how much byte it should allocate to A. And because of that only, it is giving you error. But as I said, void is a generic type. It has its own usage. So we shall see all those things in upcoming videos. So we saw how to declare variable of each type. Now let's see what is the range of these things. So here you can see for integer, okay, this data is for 32-bit compiler. If you take 64-bit compiler, this range might change. So for 32-bit compiler, integer, you will have the name as int, the keyword, and number of bytes it will take 4, which is equals to 32 bits. Then you'll have this range. How to get this range, I will explain a little later. And format specifier for int is %d. Similarly for char, number of bytes 1, format specifier %c. Float 4 bytes %f. Double small lf and it will take 8 bytes. Long double 16 bytes, capital LF. Okay. Then comes few more types like unsigned, char. By default, when you declare a variable, it is taken as signed. What is signed, what is unsigned? I will explain that in next video. So here you can just notice the difference in size and the range. For unsigned char, it is from 0 to 255. For signed char, it is minus 128 to 127. In next video, I will explain how this range comes, how these values are coming. Here you can see another type, sort int. So it is just a variant to int, short and long. Sort will obviously, it's, as meaning says, it is shortening the size. So by default, int is of 4 bytes. With sort, you will get 2 bytes. And format specifier is also getting changed to HD. So all these things, you can just note it down and you can remember. Okay. So this is it for today's session. In upcoming videos, I will explain about signed versus unsigned. Thanks for watching.